Hello everyone and welcome back to the course. In this lesson, we'll take a look at different methods and techniques that will help you think like a programmer. Keep in mind that you won't suddenly start thinking like a programmer by watching a single video on YouTube. Instead, my goal is to give you useful techniques that you can use to speed up your learning and be well on your way to writing your own code from scratch. Let's get started. So, what is a programmer? A programmer is an individual that writes or creates computer software or applications by giving the computer specific programming instructions. That is the more technical definition of a programmer, but I like to think about programmers as problem solvers. At a high level, a programmer is a problem solver. As a programmer, you start with a problem or challenge that you want to solve, and you design a solution to that problem through code. This is what I call the programmer's mindset. So then, what is the programmer's mindset? The programmer's mindset consists of taking a complex problem or task and breaking it down into simpler, smaller tasks. Then, the programmer can begin solving each smaller task via code to eventually solve the entire problem. And that is, at a high level, what you must learn to be a good programmer. You must learn to break down complex problems into smaller tasks that you can solve with the tools or building blocks that we learned about throughout the course. Now let's take a look at a simple example. I went to the Unreal Engine forums and found the following post after a few minutes. I removed the user from the image as it is not my intention to call them out, but simply use the post as an example for this lesson. The post reads, "How do I make a character dash through the air instead of double jumping?" And you can see a nice animated GIF included with the post to make it clear what functionality the user is looking for. I see questions like this all the time on the forums and on social media. The user has an idea of the functionality they want and posts a high-level description looking for help. Now let's apply the programmer's mindset to this problem and see how we can approach it. How can I make a character dash through the air after jumping? By thinking like a programmer, we can better define the problem as follows. We have two big tasks. We need to detect when the player is in mid-air or falling, and if so, we need to move the player forward. Then we can break those tasks as follows. If the player is falling, then enable the dash and disable it after the dash is completed. And then, to move the player forward, we should probably disable gravity, move the player's character in the forward direction by some distance, and then enable gravity again. This is a very simple example, yet by thinking about the problem like this, the user could have asked a more precise question such as, how can I detect if the player is in mid-air? Or, how can I apply forward movement to a falling player? In my experience, these types of questions are more likely to be answered. We will use this example as we learn different techniques in this lesson. So you might be wondering, great, this sounds simple enough, but the real question is, how do I figure out what to do to solve the specific task after breaking down the complex problem? And this is where the programmer's toolbox comes in. We spent the past 18 lessons learning about basic principles and tools we can use as coders to create solutions to various problems. Now we must learn when to use those tools when creating our own solutions. So let's go ahead and start learning about useful methods to develop that programmer's mindset. The first and perhaps the most important technique is creating a high-level description of the functionality as a simple Word document. And you can ask yourself questions such as, what is your goal? What problems are you trying to solve? What kind of code design is best suited for the solution? Then you can describe the functionality and describe detailed steps to solving the problem at hand. And here's an example of a high-level description for our air dash. For our goal, we want to give the player the ability to dash forward in mid-air. For our code design, we can implement this directly inside the third-person character blueprint. The functionality can be described as the player can press the dash key while in mid-air to dash in forward direction once. And the steps are as follows. The player jumps. While in mid-air, the player presses the dash key or jump button again. We disable the gravity to prevent the player from falling. We move the player in the forward direction by X distance. Once used, we disable the dash key, and then we enable the gravity so the player can fall. Next, we want to convert our detailed steps into pseudocode. But what is pseudocode? Well, pseudocode is a plain language description of the steps in an algorithm or another system. Pseudocode often uses structural conventions of a normal programming language, but is intended for human reading rather than machine reading. In other words, we want to convert our steps to start using some of the coding conventions we learned about to make it easier to convert to full code once we go into Unreal. And here's an example of some pseudocode following the steps above. The player hits the input action jump, then a function called function isPlayerFalling is called, which returns a boolean. If the boolean is true, we do a branch with a variable called canDash. If that returns true, we set canDash to false, we set gravity to 0, and we call a custom event that uses a timeline to set the player's location in the forward direction. When that is done, we set gravity back to 1 again. And if the original function returns false, meaning we are not falling, we simply proceed with the jumping ability and we set canDash to true. Then, when we are implementing our code, we can follow two approaches. One, we can take a top-down approach, which means that we lay out the high-level parts of our functionality first, and then we iterate by breaking down each high-level part into smaller parts. We also want to start simple and evolve into the complex. So start implementing the simpler high-level parts of your code first, and iterate with more and more complexity on each pass. So here's what it looks like when you're putting everything together. For the design phase, you want to start with a high-level description of your functionality. You can use Notepad or Word to lay out all of that information. Then you convert those steps into pseudocode to better approximate how the final code will look like. Then, during implementation, meaning you're now in Unreal Engine, you want to start with big tasks and break them down with each iteration. You also want to start simple and add more complexity with each iteration. And notice the arrows there. We are going to iterate or repeat those steps over and over, starting from a high and simple task to the more granular and complex. With each iteration, we add more and more functionality until we end up with the final desired functionality. Now let's jump into Unreal and follow these steps to create our air dash. Okay, and now that we're back in Unreal, let's start by opening our third-person character blueprint here. We're going to scroll down on the event graph where we have the input action jump. We're going to be building our air dash using the jump button, and we're going to move these nodes to the side here to make a bit more space. And as we talked about, the first thing we need to decide is determine when the character is either falling or flying. So we're going to make some space here. And as I mentioned before, we don't want to reinvent the wheel. Unreal Engine comes with a lot of built-in functionality. So I always suggest, before trying to do something from scratch, go ahead and right-click and start searching for functionality. So maybe we search for the keyword air and we scroll down and it doesn't seem like we're finding anything useful here. How about if we type fly? And immediately we see that we have a function called isFlying. So if we select it here, we notice that the character movement has a function that returns a boolean whether our character is flying or not. That may be useful, but flying is an actual movement mode and we don't want to go that route. That would make it a little bit more complicated. So let's go ahead and search for something else. What about falling? And we also know that again, the character movement has a function called isFalling. And this actually may be a little bit more useful since we don't have to do anything specific. All we need to know is whether the character is falling or not, and it returns a boolean. So right there, we can quickly determine whether the character is in midair or not. So let's go ahead and remove the isFlying here since we don't need it. And we're going to add a branch right here using this return value. Alright, so right now we have done the very basics of our first big task. We are determining whether the character is in midair or falling right here. And now if the character is not falling, meaning the character is on the ground, we want the character to jump. So let's go ahead and change this here and move it down here. But now if the character is falling, meaning we press the jump button and we are in midair, we want to move the character forward. And yet again, before we start trying to do something from scratch, we can try and search for built-in functionality in Unreal Engine. So yet again, if we right-click, we're going to find that there are several ways that we can move our character while it's in midair. The first one is called Add Impulse. And you can see that we can add an impulse to the capsule component, to the mesh, etc. So if we do Add Impulse Capsule Component, we can see that we have a node here that would add an impulse to a single rigid body and is good for a one-time instant burst. So that may be an option for us. There's another option called Add Force. And you notice that we have an Add Force for the character movement component. And there's also a bunch of different options under the Physics tab, meaning that we will have to be simulating physics to be able to use these nodes here. So we can select this Add Force for the character movement. And we see that we have another option that we could use to move our character in midair. And if we hover over, we can see that this is a force that is accumulated each tick and applied together, so multiple calls will accumulate. So if we use this node here, it would probably be best if we use it either on tick or on a timeline. Basically, we want to call this multiple times. But there is yet one more node, and it's called the launch node. So let's search for launch. And you can see here it's called launch character under the character category. And this is a single node that will launch the character by taking a simple velocity vector into a direction. And it doesn't need any special settings for physics or anything else. And if you read the description here, it also conveniently says that it will set the character to the falling state once you launch the character, which is great because we're using the isFalling function here. You could use any of these options, but in this case, we're going to use the launch character as this is the simplest way of accomplishing our goals. So let's go ahead and remove these. And now we know that we want to launch our character if we press the jump button and we are falling. Now the next thing we need to do is to provide the launch velocity. And we've done this before when we talked about traces. We want to get a direction. And the way we would do that is we would get the actor's rotation. Then we can get the forward vector from here. And using the forward vector, we want to multiply this by a float. And we can create a new variable here of type float, and let's call this dash speed. We can drop it here and connect it to our multiply node. And right here we have the direction. We want to move in the direction of the forward vector, that's the front of our character, by a specific speed. So we can connect this here. And now let's go ahead and set our dash speed to something like 1000. And let's take a quick look at our code. When we press the jump button, we are going to determine whether we are falling or not. If we are not falling, meaning we are standing, we are simply going to jump. If we press the jump button again and we check one more time, are we falling? If it is true, we are going to launch our character towards the front or the forward direction by our dash speed, which is in this case 1000. This node also has two very handy booleans here that allows us to override the x and y and the z values. And this is again if you want to override momentum, right? If you're running and you jump, if you want to nullify those forces, you can just go ahead and check these right here. And we're gonna go ahead and do that here. It'll make it a little bit more obvious once we actually launch our character. So let's go ahead and click compile, save, and let's test it out. Right here, we're going to click play. And I'm going to look on the side of the character and I'm going to jump and press my jump key while I'm in midair. And you can see that we actually launched our character forward. Let's try that again. Perfect. Now you'll probably notice a slight problem. When we air dash, our character is going down, and that is because we have gravity enabled. So that is the next thing we need to address. So let's go ahead and go back to our character. And here in our code, we have to figure out what controls our character's gravity. And right here, you would think if we have a character here with our movement component, if we click on our movement component here, we can probably find some information about gravity. And if we start scrolling here, the very first section here called Character Movement General Settings, you see that we have a gravity scale value, 1.75. That's great. All we need to do to disable gravity, in other words, would be to make that scale 0. And we know how to do that now. We can just drag our character movement and search for Set Gravity Scale. And if we set it to 0, that means that our gravity would be 0. And we want to do that just before we launch our character. So let's go ahead and make some space here. And now we see that we're going to set our gravity to 0. We're going to launch our character. And after we launch our character, we want to enable gravity one more time. Otherwise, our character will just kind of stay floating in the air. So let's go ahead and copy the node here. And we'll connect it here. Now there's a small problem, which is as soon as the character is launched, we are going to enable gravity back to 1.75. Let's enter it here. But that will happen the instant we launch our character. So we probably want to add a delay to allow our character to move without gravity for a small amount of time. So let's go ahead and add a delay node in between. And in this case, we can add the delay node of half a second. All right. So now we've set gravity to 0. We launch our character. We wait for half a second. And then we reapply gravity one more time. Let's go ahead and test this out. Press play. And just like before, I'm going to look from the side and press the jump key and press it again while in midair. Now look at that. Now our character is flying through the air without any gravity. And then after half a second, gravity is applied. Excellent. However, there is one more issue we need to address, and if you're following along, you may have already noticed. There is nowhere in our code where we are controlling how many times our character can dash in the air. So let's press play one more time, and this time I'm going to move to one side of the room here. And if I just jump and press my jump key again, but keep pressing it before the half a second mark, my character will continue to dash forward indefinitely. Let's try that out. There you go. So that is the next thing we need to address in our code. How do we limit the user from only dashing once while the character is in the air? Let's go ahead and stop. Go back to our character. And let's think about this for a second. We are going to press our jump button here. And if our character is not falling, we want it to jump. We don't want to limit this. What we want to limit is this part of the code right here. So let's make some space here. And we can probably create a simple Boolean that will tell us if we can dash or not. So let's go ahead and create a new variable. Let's call it can dash. Let's make this a Boolean. And now let's add another branch here and add our new Boolean here. So if we can dash, we want to then disable the dash variable here and then go ahead and continue with our code. So let's go ahead and drag can dash one more time, but this time we'll select set can dash and we'll leave it as false and we'll connect it. And now we're saying if we can dash, disable the dash and proceed with our code. If the user presses the button one more time, when he gets back to the branch here, it'll be false and the user will not be able to dash one more time. However, we need to find a way to reset this value to true. And probably the easiest place would be right here. If the character is not falling when you press the button, it means that you're on the ground. So we can then jump and then reset our dash variable here. So let's go ahead and copy it one more time here. But this time we want to make this true. And yet again, look at our logic here. If the character is falling and the character can dash, which let's make this true as our default value. We want to start with the ability to dash. This will be true. We'll set can dash to false and we'll execute our code that will dash our character. If the player presses the button one more time while in midair, right? This will be false and nothing will happen. Once the character lands and the player presses the jump button again, this will return false since we're not falling. We will jump and immediately allow our character to dash one more time. So let's go back to our third person map and let's test it out. Just like before, I'm going to go to the side, I'm going to jump and start pressing my jump key many times to see if I can still dash indefinitely. And you can see that now we have fixed that issue. Great. I think we can probably go back to our character and looking at the code that we have here and the original question from that user, we can probably stop here and say, hey, we implemented an air dash that does a dash speed of 1000 for half a second. We disable gravity and the user can only dash once. That was the original question. But let's go ahead and take this a little bit further. In many games, I've seen that there's a new power-up. Instead of just doing a regular dash, you can do a directional dash. I've seen many games do that and it's quite fun and fairly easy based on the way we have our code. So let's go back to our launch character node here and you'll notice that we are always doing the forward vector of our character. But what if we used the rotation of our follow camera instead? Let's go ahead and try that and see. Drag our follow camera. And from here, we're going to get the world rotation. And now we're going to plug this value to get forward vector. And now instead of getting the actor's rotation, which is the actual character, we're going to use our camera's rotation, which then will get our forward vector of our camera and will launch the character in that direction. Let's go ahead and compile and save. And let's go back to our map. And now let's see what happens. I press play. Now I'm going to look up, and when I jump and press the dash key again, our character is now launched in the direction that I'm looking. Now I'm going to look towards the right side of my character, and as soon as I jump and press the key, let's see what happens. Notice that the character is now being launched in whatever direction I am looking. You can do it back. You can even jump and look down and do it like this. So now with a small tweak, we have added a simple forward dash and we have upgraded the ability to be a directional dash. Now let's go back to our character and look at our code one more time. And even though our code is quite simple, you're probably thinking that is great, But what if I didn't know, or I didn't find a node such as is falling? Or what if you didn't even know that the launch character node existed? And that is true. You don't know what you don't know. So even though I always advocate for trying to find something that is already pre-built in the engine, no point in reinventing the wheel, there will be many cases where you don't have that built-in functionality and you have to build the functionality yourself. So now what I'm going to do is I'm going to build from scratch the isFalling function here and the launch character functionality here from scratch. And I'm going to do it, and I'm going to fast forward the process, because the point isn't for you to follow me step by step, but for you to see my logic. So let's pretend for a second that this functionality was not available in the character movement component. We still need to figure out a way to determine whether the character is falling or on the ground. How could we do this? Well, let's go ahead and build it from scratch. Alright, so let's see what I did here. I created a new function called function isFalling. I am doing a simple line trace by channel. I'm starting with the actor's location. I'm grabbing the actor's rotation and the up vector. And if you recall from our previous lesson, you can invert any vector by multiplying it by a negative number. So I'm grabbing the actor's up vector looking up, and I'm multiplying it by a negative distance of 100 units. Then I'm adding that to the actor's location, and that would be the end. What we're effectively doing is doing a trace straight down towards the floor by 100 units. And this return value is true if we hit anything at all. So if we actually hit something, it means that we are on the floor and not in the air. But we want to know if it's in the air. So we can use the not node here to invert the Boolean from true to false and false to true. So if this returns true, meaning we are on the floor, we hit something, we're going to invert it and make it false, because it means we are not on air. And now if we go back to our event graph, we can simply use our function here. Let's drag it, function isFalling, and we can replace this node right here. And now let's go ahead and test it out. And let's see what happens when we try to dash through the air. Notice that we have the trace right there, and it's using the exact same logic. You see, all of the traces did not hit anything, which would return true, we are in the air, and it allows us to dash. There you go. Now let's try to recreate the second node, which is the launch character node. And there are many different ways that we can move our character's location forward or in any direction on a specific amount of time. In this case, I'm going to use a timeline because we've used timelines before in this course and you should be familiar with it. So let's go ahead and do just that. Alright, so what I've done here is I've created a custom event called EV Air Dash. I created a new timeline of half a second, and that timeline is linear. And then on the update, I am adding an actor world offset, meaning we are taking the current location of the actor and we're offsetting it by a specific vector. And we can use the same code as before. We have our forward vector of our camera, and then we're simply multiplying it by a dash distance. And in this case, the value is 10. Remember, we want to make this value small because we are going through this every single frame. We are basically hitting this update for half a second. Then we're simply multiplying this by this and adding this as the delta location. Simple enough. And now if we go back here, all we will need to do instead of doing this is simply call our custom event. So let's go ahead and do that. And now, after the gravity scale is set to 0, we call our custom event, which we know will last half a second because our timeline is half a second. Then we wait those half a second here, and then we again enable the gravity. And while this timeline is running, we are simply adding an offset to the character in the forward direction of our follow camera multiplied by our dash distance. Let's go ahead and try that out one more time. And yet again, we're going to press the jump button and then look somewhere and jump again. And notice that it works pretty much the exact same. And now for the last thing, I like to do a little bonus segment here. Let's go back to our code and look at it. We see that we have now done a custom function to detect whether our character is falling. We have now a custom event that actually moves our character in a direction by adding an offset. What if we wanted to configure how many times our character could dash while in the air? Originally, we didn't have any restrictions here and we could dash indefinitely, but now with our current setup, we can only do it once. There are many games out there that provide, let's say, upgrades to abilities where you can dash maybe twice or 3 times in the air. So I want you to pause this video now and really think about how would you add a set number of air dashes if you were trying to add that to your game. So I'm going to give you a second here. Think about it, use the methods that we talked about in this lesson, and really try to add it yourself and see if you can do it. Alright, hopefully you were able to figure it out, but let's go ahead and add that here as a little bonus. So right now we're doing a simple boolean, a true or false. But what if we simply had a variable that counted how many times our user, our player, pressed the dash key? And we can do this fairly easily. So let's create a new variable and let's call this dash counter. And instead of a float, we can actually make this an integer. And so we're simply counting from 0 to how many times the user has pressed the button. And we're going to create one more variable and let's call this total dashes. And the total dashes is the amount of dashes that we are allowing the player to make while the player is in the air. Let's make this 2 for now. And now, instead of using this boolean, let's go ahead and remove that here. We are simply going to compare our dash counter to our total dashes. So if we grab our dash counter here and our total dashes, I can say if the dash counter is less than the total dashes, that means that we can dash. And if so, we want to add 1 to our dash counter. So we can simply drag our dash counter one more time and search for ++ and use the increment int by 1. And this node simply takes whatever value this integer has and simply adds 1. So now we're saying every time the user presses a button, we're checking the dash counter, which is 0, and we're saying is 0 less than, in this case, 2. If it is true, we're going to increase the dash counter by 1 and then go ahead and dash. If the user presses it again, the second time this value will be 1, which will still be less than 2, and the user will be able to dash again. But because we're adding 1 each time, the third time the user presses the button, this will return false because now the dash is the same as the total dashes. The dash counter is the same as the total dashes. 2 is not less than 2. This will be false. The user will not be able to dash. And the last thing we want to do is we want to reset our counter when our player lands. So we can do it right here. We can simply grab our dash counter and select set dash counter to 0 after the player jumps. Let's test this one last time and try to dash. In this case, I'm limiting my dashes to 2 while in midair. So you can see it is working, and you can see that we are dashing twice in a row. Let's go back to our code and look at the final version here. We started with a simple premise. How can we add an air dash to our character? We followed the steps that we talked about in this lesson. We used our programmer's mindset. We broke the problem down into simpler tasks, and then we attack each individual task by using our tools that we learned throughout the lesson to create code that would basically solve that problem. We are detecting if the character is falling with a line trace, which we learned about. We are using a simple counter system here to allow the character to dash an arbitrary number of times. You can simply change this number to whatever you want. We are then disabling gravity. We're calling a custom event. They're using a timeline to add a world offset to our character in the forward direction of our follow camera. We are then waiting for half a second, the same amount of time as our timeline, and we are then applying gravity one more time. Fairly simple functionality, but as you can see here, we used all of the things that we talked about earlier. We started by breaking down the problem from just a statement to bigger tasks, and each individual task breaking it down into further individual tasks until we were able to design our solution through our code. We also started simple by implementing the basic functionality, and then through iteration we added more and more functionality until we got this feature to where we wanted it to be. And as a bonus, we added additional things that the user didn't even think about, like a directional dash or how many times we can allow the character to dash while in midair. So let's do a quick recap. Programmers are problem solvers. The programmer's mindset means taking a complex problem and breaking it down into simpler, smaller tasks. Some of the methods to develop the programmer's mindset include, well, create a high-level description of your functionality. Convert your detailed steps to pseudocode. Start implementing the big tasks first, then proceed with the smaller ones. Start with the simpler tasks and add complexity with each iteration. Continue doing this until you arrive at the desired functionality. If you want to practice what we learned, think of your favorite games and pick 3 simple abilities you can add to your game. Some examples to choose from include a double jump ability, a sprint ability, and a teleport ability. Use the methods discussed in this lesson to create them from scratch. And finally, if you're up for it, post in the comments section below and let us know how you did. And that's all for this lesson. Thank you so much for watching, and I'll see you in the next one.